All right. Depending on how I approach this last couple sections here are the answers for 10.7. We may have not completed 10.7 yet, and if we haven't, that's okay. Just note that these answers are here because I sometimes do 10.8 first and then 10.7. So I'm just going to include those in the video here. Okay, 10.8 is comparing linear, exponential, and quadratic models. So what we're going to do is based off of how the data looks, we're going to be able to tell whether it's linear, exponential, or quadratic. So we've studied all three of these types of functions. Now what we're going to do is kind of put them all together and kind of review them and see how they differ. And it's nice to review them. So we have the three different types. We have linears, which is y equals mx plus b. We have exponentials, which we study in chapter 8, y equals a times b to the power of x. Maybe I've forgotten about that. And then we've got quadratics, which are ax squared plus bx plus c. So if they're in those forms, you can tell what they are. And if you are given a set of data, you can figure out what it is by analyzing that data or the table of values. So here gives us three sets of data points here, and it says tell whether it's linear, it's exponential, or quadratic. So what you can do is you can graph them, you can plot them on grid paper, and then look at the shape of the graph. And sometimes you can look at the numbers too, and I'll show you that. But this is the first method of determining it. And I'm just going to show you guys if you were to graph them, what they would look like. And so you can see here the numbers for the y values are growing and getting bigger and bigger and bigger. That's our exponential. Here, 1, 2, 3, 4, 5. If you plot those points, that's going to be linear. And then here it goes 5, 2, 1, 2, 5. And that's going to make our U-shaped because it goes down and then it goes up. That's our quadratic function. And then you can take a look. I know there's a lot here. Okay, so let's I'm gonna put up a thing here so it's just not super overwhelming. Okay, so difference in ratios. A table of values represents the linear functions if the differences of successive y values are equal. So that's seeing what it's going up by. So this is it's adding 3 every time. And that's kind of like what I was saying over here. It's adding 1 to the y values every time. It's going up by 1. That's going to tell that it's linear. For an exponential, it's going to be multiplying. This one's multiplying by 2, multiplying by 2, multiplying by 2. And if you don't notice that, you can divide 2 divided by 1. You can divide 1 divided by 0.5, 0.5 divided by 0.25, and it equals 2 for all of them. That's going to show you that's our common ratio there. And then, let's see, actually I have some boxes here. So as I said, linear adds and subtracts, and then exponentials multiply and divides by the same amount. And then we have quadratics, and quadratics are kind of interesting. As I said earlier, it goes down and then it goes up, but you might not notice that based off of where the table is. For example, if you didn't see this part of the table, it'd go 1, 2, 5. You wouldn't know that it's going down and then going up. So it's important to recognize this it's called first and second differences. So from 5 to -2, it's -3. And then from -1 to 2, it goes, I'm going to start this over. Okay, so from 5 to 2 it goes down 3, from 2 to 1 goes down 1, from 1 to 2 goes up 1, from 2 to 3 goes up 3. None of those numbers are the same. So what we do is what we look at is the second differences, and that's what tells you it's a quadratic. So from -3 to -1 goes up 2, from -1 to 2 goes up 2, from 1 to 3 it goes up 2. The second differences are all going to be the same values. And then I have a little note here. Make sure that the x values are always going up by 1. The x values will always go up by 1. So you'll notice here they go up by 1 as well. If they don't go up by 1, you're going to have to fill in those missing table values there. So there's a lot on this slide. And key things to take away. Linear adds or subtracts by the same amount. Exponential multiplies or divides by the same amount. And quadratics, we look at the second difference. There we go. So let's take a look at some sample problems. Here, if I look at these, I'm just going to make a table. 0, 1, 2, 3. You could graph this, but I generally don't like to graph if I don't have to. Okay, so I noticed that the numbers are getting bigger. So let's see. It's adding 1, then it's adding 3, then it's adding 5. So that's the first difference. It's going up by 2 and up by 2. So that would actually be a quadratic. Okay, let's take a look at the next one here. And I've noticed some multiplication here, multiplying by 5 every time. And if you don't recognize that, do 10 divided by 2, that's 5. Do 2 divided by 0.4, that's 5. Do 0.4 divided by 0.08. If you divide them, you're going to get the same number. So that's going to be our exponential function. Okay, then what we're going to do now is we're going to write the equations. We spent a lot of time writing the equation for it. First, we got to identify what it is, then we're going to write the equation. So what I notice here, like this one, you can just tell it's quadratic because it's reflexive. It's going to make a U shape. So I know it's going to be a quadratic. For this lesson, anytime that we have a quadratic, it's going to be ax squared. We're not going to have the bx plus c. You guys are going to do that in high school math. So what we want to do is we want to just go y equals ax squared, pick any point, any non-0, 0 point. Plug it in. So I'm just going to use 2 and 2. So plug in 2, plug in 2. So 2 equals a times 2 squared. And then divide by 4. So a equals 1/2. So equation is y equals 1/2 x squared. So there you go. The book is going to go through all of this here, and it becomes quite complicated. Like I said, this is what the book wants you to do. It's a lot of work, right? Okay, if you want to write that down, you can, but you don't need to. What I wrote down over here is what you need. And this little blurb here is just make sure you're not using 0, 0 to plug in to figure out what your a value is. So that's how you write a quadratic. Tell whether the function represents linear exponential function, then write the function. So I'm just going to go plus 2, plus 2, plus 2, plus 2. So that's y equals mx plus b. It's linear. Okay, my slope is 2, so y equals 2x plus b. My y-intercept is right there when x equals 0, so y equals 2x minus 1. That should be a review for you guys who've talked about linear before. This one makes a quadratic. I'm not going to do the same problem. We just did a quadratic. All right, I will go over this question with you guys in class. Because I think my video is getting, I'm going to check my timer on my video. Yeah, I'm at 9 minutes already. So we'll do this one in class. And here's your assignment. Thank you guys for tuning in to 10.8. We're going to be doing an extension of this with the graphing calculators. And that I think you guys will enjoy. So let me know if you guys have any questions, and I will see you in class.